All right, so PHP. So PHP is fundamentally different from C in that it's not compiled, it's interpreted. And an interpreted language is something that you still write in the same way with source code, but you don't actually run it through a compiler and then run the resulting executable. Rather, you write your source code, then you run an executable, and you pass to that executable the PHP source code as its input, as its command line argument, really. So in the world of PHP, the interpreter is generally a program called php.exe, on Windows at least, or php.app on Mac, or PHP on a Linux system. So what's nice about interpreted languages is that they actually lend themselves to much faster programming. You don't have to jump through as many hoops to actually get your code working, and they tend to be much higher level in the sense that you don't need to worry henceforth about pointers and locations in memory. You don't need to worry about memory management anymore. Rather, the interpreter, in this case PHP, is going to handle a lot of that minutia. Interesting details, but tedious details as you advance further in your understanding and savvy with programming. So just to give you a sense of PHP, here is perhaps a wonderfully recommended resource that just talks about the language. Here's a loop, here's a condition, and so forth, so that rapid fire you can acclimate to the syntax. And you will find PHP syntax very similar to C, which is one of the reasons we use it at this point in the course. In terms of functions, though, one of the nice things is that we also don't need to adhere to this convention of having a main function anymore. Rather, if you want to write a program in PHP, you open up a text editor, you create a new file, and you just start writing PHP code. You don't have to have a main function per se, but you can have and will have other functions that you write or that you use. So conditions look just like this. And this is the exact same slide we showed in week 1 when we started talking about C. The general format for conditions in PHP is going to be the same. In the case of Boolean expressions, these are going to look the same, both with ors and with ands. Switches are going to be the same. In fact, switches are a little more generous in PHP in that you don't need to just compare integers or chars. You can actually do string comparisons using these cases. So that's actually a little more friendly and versatile as well. Loops are actually going to look the same. You're going to have for loops. You're going to have while loops. You're going to have do while loops. And so this ultimately is to say that we're going to see a lot of familiar syntax. We also have arrays in PHP. But the nice thing about PHP's arrays is that, one, you don't have to declare their size in advance. If you want an array, you effectively just say, give me an array, and then PHP figures out what size it should be. And if you keep adding and adding and adding and adding to it, PHP will take care of resizing it for you. You don't have to worry about malloc and realloc and all of these lower level details anymore. The language is, again, much higher level. You also have variables, but variables syntactically you'll find are a little different. For better or for worse, every variable in PHP is prefixed with a $sign. The upside of this is that it really is obvious what is a variable. The downside is that you have $signs all over the place, but this is just the convention that these folks chose. So in this snippet of sample code here, I'm declaring a variable called s. I'm setting it equal to a value of hello world. And then notice what I'm omitting. I'm not specifying the word string. I'm not specifying the word char star. In fact, when you declare variables in PHP, you're no longer going to specify the type of a variable. Rather, PHP is going to figure it out from context. And indeed, the context here is pretty obvious. The double quotes obviously suggest this is a string, so there's no need for us, the programmer, anymore to say string s or char star s. Same in the case of floats and integers and even booleans, so we relax that constraint. PHP is loosely typed, whereas C is a strongly typed language. And so this has both upsides and downs, but for now, it means that a lot of the syntax that you might have struggled with for some time will start to slip away. So loops, too, have some nice new features. It's a very common paradigm in PHP to want to iterate over an array, because PHP is very often used in web programming. Web programming often involves databases. Databases often involve lots of data, and so it makes sense that you might want to iterate over a whole bunch of data, like your list of friends or your stock portfolio, and print out the same kind of information again and again in a loop. So PHP has this very nice for each construct that C did not have, and the syntax is generally as follows. For each, and then in parentheses, you specify the name of an array that's stored in a variable. In this case, I arbitrarily called the thing array, $array. For each array as element, as is just this new keyword, $element is also arbitrarily named. But ultimately, inside these curly braces, I can now do this again and again with $element. And on each iteration of the loop, PHP is going to automatically change what value is in element by taking the next element from array successively. I don't need to do plus plus. I don't need to do that sort of manual manipulation anymore. But perhaps most powerful about PHP and a lot of these higher level languages, Ruby and Python and the like, is that they support something called associative arrays, which is just a new word for what we spent the past week on, namely hash tables. Those of you with Java backgrounds might have called these things hash maps back in the day, but an associative array is simply an array whose indices no longer need to be numbers, right? Up until now, anytime we've had an array, that you index into an array by way of bracket 0 or 1 or 2 or 3, and that's a little limiting because in problem set 6, you wanted to answer questions of the form, not where is this word, but is this word in my hash table or in my trie? And so in the case of hash tables, the input to your check function was typically the word that the user that had been pulled from the Austin Powers script, for instance. And so you wanted to say, is this word foo in the dictionary? And you wanted to use foo as your key and get back a value of true or false. Well, PHP makes this so incredibly easy that you can re-implement the entirety of problem set 6 in just a couple of minutes. And so, in fact, let's see how we might do this. I'm going to go over to my sorry, should have told you last week. So let me go over to my appliance. I opened up gedit. I created a new file called dictionary.php. And I'll go ahead and start typing this. So the one distinction with PHP that you have to remember is that you can't quite just start typing code. You actually have to tell the interpreter that you're about to start writing PHP code. And so the convention the world adopted is that if you're writing a PHP program, the top of your text file should have open bracket question mark PHP, and then at the bottom of your text file should be essentially the opposite, but without the word. So question mark angle bracket. So most web servers, though, actually allow you to shorten this to just this. There's a good amount of religious debate on the web as to which is better. Frankly, I think this is much simpler and more elegant. And so you'll see, at least in a lecture examples in the problem sets, that we use what are called short tags. We don't bother writing PHP all over the place. But what these tags mean, and these are not HTML tags, these are, for better or for worse, PHP tags. This means here comes some PHP code. And so I can start implementing problem set 6 by thinking ahead as to what I need. Well, ultimately, I'm going to want, for instance, a variable. And I'll call this size. That's going to represent the size of my dictionary. I also want to have an actual dictionary. And so a dictionary, I like the approach of a hash table. Just conceptually, it's easy in that you insert a word and you want to get back true or false. So that begs an associative array. And to declare an array in PHP, one of the ways is literally call a function called array, open paren, close paren, and that gives you now an array of size 0. But recall that arrays in PHP will resize themselves, and their indices, the thing in square brackets, no longer have to be numbers. And so that allows me to do things like this. Let me now scroll down, and let me start implementing something like the load function. And I'll call D the name of the file that's being loaded, so large or small, as in the case of problem set 6. And I have to do something a little annoying in PHP. I actually have to say global size and global dictionary only because when I'm inside of a function, unlike C, I need to say explicitly if I'm trying to use a global variable. With that said, global variables are not all that common. I've simply gone this route because it's nice and simple to get started here. So let me do something error checking oriented. So if it is not the case that this dictionary file, $D, exists, I'm going to go ahead and say, if not exists, I'm going to go ahead and say return false. So if D does not exist, return false. And also, just for good measure, if not is readable, D, go ahead and also return false. So you didn't focus on these lines so much in your own implementation, since we wrote a lot of the error checking code in speller.c. But these are now PHP functions that just come with the language. And they're a lot easier than some of the techniques we had to deal with in C. But believe it or not, the load function is almost done. I'm going to go ahead now and use this new construct for each, let me say, let's call this, let's do this. Words gets file of D. Turns out that file is a function that loads in a text file, and for each of its lines, puts each of those lines in a different element in an array. So at this point in the story, words is an array containing every word from the dictionary. So now what I want to do is a little something like this. For each of those words, as, let's call it word. So this is the construct that's like a for loop, but it's going to do all the auto incrementation for me. So for each of those words in the array as a word, I'm going to go ahead and do this. Dictionary, word, gets true. Size, plus, plus. Done with my load function. Right? How is this actually working? So dictionary is an associative array. An associative array is just an array whose keys no longer need to be numbers. They can be actual words. And just like an array with numbers associates key with value, number with value, an associative array can certainly associate word with value, or in this case, word with Boolean. So now I have this amazing data structure that took me one line of code to implement that I can just say $dictionary bracket word close bracket gets true. And what's that going to do for me? Well, PHP is going to figure out where in this data structure called an associative array to put that word, and it's going to store the value of true. Yes, 1, whatever the implementation may be in that data structure. And size plus plus is just like C. Now, I need to actually do one little thing just for good measure here. I should probably do this. I should probably, actually, the one little thing I do have to do, I have to say word gets chop word, in case you're playing along at home, only because the file function is not quite smart enough to get rid of the new lines at the end of each line. So if I want to get rid of those new lines, chop is one way of eliminating the white space at the end of that word. But I don't have to deal with lowercase or anything like that, because recall that the dictionaries we allowed you to assume would be lowercase. So return true. That's it for the load function. And really, the magic is in here. The rest is just error checking and syntax. So what about, how about size? Well, size was pretty easy for all of us, but let's just do that one for good measure. So function size. Now I can say global size, return size. Silly though that may seem here, but it's also certainly pretty simple. And now let's do check. Check was kind of the interesting one, because that's the one that was called again and again and again. So let me scroll up to the top of my file. Do function check. This time I'm going to be checking a word. Let's arbitrarily call it W. And in here, I need access to the dictionary, so I have to deal with that little syntax. But now I can just do this. First, let me force the word to lower. So stir to lower is a function in PHP that changes a string to its lowercase form. And so now I can just do this. If in the dictionary array at location W equals true, well, return true. Else return false. Or if you really want to be fancy, you can just say return that. Bam, problem set 6. So why the hell did we just implement problem set 6 in C? Well, the reason that these associative arrays and languages like PHP and Ruby and Python exist is because of languages like C. And the fact that this is pretty darn easy to write is because we've stood on the shoulders of these previous languages. In fact, the PHP interpreter, the program that we're about to use to run this program, itself could be written in C. And the same thing for interpreters for other languages, because C, as we will see in a moment, is actually very high performing. And so actually, in the real world, when you really care about the performance of your code, as we did for problem set 6, you might want to sacrifice some rapidity of developer time, put more time, put, dare say, a week, 20 plus hours into that implementation so that you really squeeze out all available or all possible performance. So let's see what actually happens here. I'm going to go ahead and go into my terminal window here. And in here, I have two files at the moment, dictionary.php and Speller. And just to show you what Speller is, let me go ahead and open Speller. Speller is also implemented in PHP. And we won't spend time going through this, but pretty much I sat down one night with the C code open, with a blank file open, and I just started translating in my own head the C code to PHP, trying for every line to call the nearest equivalent PHP function. So as an at-home exercise, definitely look through this Speller file, or if you have a printout here today, but just realize that it's almost a direct translation from C to PHP. So as such, it's a nice way of understanding how to go from one to the other. And let me point out one little thing here. You will see in a lot of interpreted languages, even though they're just written as text files with simple text editors, at the very top they have this silly thing called a shebang, a sharp, a bang, /user, /bin, /something. So this simply means when this file is executed at a command prompt, run this interpreter and pass that interpreter all of the lines below it. So it's a way of naming your files very simply, like Speller, as is the case here in my terminal window. sudo, but I don't have to specify a file extension and therefore tie myself to a specific language. I can literally just run speller as we could in C. And thanks to that first line in the speller file, the operating system will know what to execute. So let's go ahead and run speller in the PHP version on cs50/pset6/dictionary, no, not dictionaries, texts, and then Austin Powers, for instance. So let me go ahead and run this. All right. So we've got that. Looks like there were 644 words misspelled. Words in dictionary seems to check out, and this took about half a second, so 0.53 seconds. Well, now let me go into another terminal window. In this window, I have implemented pset6 using C. So this is my C code from pset6. I've already compiled speller, so let me do the same thing. Speller on cs50 pset6/text/Austin Powers. Enter. Whew. OK, so I'll zoom in. This is before. Whoops. Oh, I ran it the same way. This is before. Sorry, this is after. 0.03 seconds. And now if we go back to our misspellings for just a second and run this again here, feels slower, right? We can do this really explicitly. Speller. OK, even got faster that time. Before, after. Before, after. For those who can't see in front, same story. Before, after. Before, after. So this is the price you pay. And it's not clear, perhaps, at first glance, if this is now a net positive. It feels like we're about to introduce you to a really crappy language, right? Because now you can write much less code, but my God, look at the price you pay. It's an order of magnitude different. But this is a little misleading as such. So on the one hand, I'm actually doing things a little less efficiently in PHP as I could be here, because I'm just trying to make it map as closely as possible to problem set 6's C code. But also realize this. We are paying a fundamental penalty. Not the result so much of PHP, but the result of PHP being an interpreted language. Whereas C is compiled by GCC into zeros and ones that the underlying CPU understands, well, PHP is not compiled into anything. Rather, we're running a program, php.exe. We're passing it all those lines of code we just wrote, plus speller, and saying, please figure out how to execute these. And an interpreter pretty much goes top to bottom, left to right, and converts as best it can each line into the equivalent zeros and ones, but on the fly. And if I run my speller again, the interpreter has to reinterpret it. If I run my interpreter a third time, it has to reinterpret it. So one of the disadvantages then of an interpreted language is you might be doing all this work right at the very front to interpret your program, but then you're throwing those results away because the program is not saved. It's because it's not compiled. Now let's fast forward to the context of the web. So the reality in the world of the web is that computers are not the slowest part. We have a whole internet between us and someone else across the country if we're trying to have two computers communicate. And so there's a lot of other delays that actually might mean that, you know what, it's OK if it doesn't take a split second, but 2 split seconds. All right, so we might be able to tolerate that performance penalty. And also, in web servers, which we're about to go back to, you can actually cache PHP. So you can enable a feature whereby once a PHP file is interpreted once, the computer, the web server, will actually remember how to do that again so as to save time. And so you will find that a super majority of startups these days, of websites on the web, actually do use these high-level languages like PHP and Python and Ruby and Perl and even others, because C is the wrong language with which to implement most websites. Once you're at the point of Facebook scale, Google scale, and even a little smaller than that, certainly there are small problems that you might want to solve at the very low level with C, doing database queries or searching graphs of social networks and the like. But for implementing something that just spits out HTML and spits out a stock portfolio and even prints out your list of friends, by all means, is an interpreted language like PHP a better choice than C. Case in point, took just a few seconds to implement the entirety of a week's work. So just realize these trade-offs. So let's transition then to actually running PHP code on a web server. Right now I ran it at the command line, which is absolutely possible with one of these interpreted languages. But if I instead move my PHP files into my public_HTML directory or somewhere like that, I can actually have the web server execute my PHP code so that I, the human, no longer need to manually type commands. And this is perfect, because when a user visits cs50.net, obviously we don't want a human having to run a program saying, respond to this user. It's all automated by the web server. So let's then transition back to where we left off last week on something like implementing the freshman intramural site. So let me go into my jharvard directory, public HTML, and one of the files I have in here today, it's all on the cs50.net/lectures, is froshIMs0.php. And this is a simple version of where we left off last week. So notice we have some familiar stuff now. Doc type just means here comes a web page written in HTML5. The HTML tag is the root element, which says to the browser more explicitly, here comes the actual web page. The head of the page comes next, then the body, and the real interesting stuff typically happens in the body of a web page. Now, we haven't seen all of this HTML in detail yet, but frankly, it's pretty easy to pick up as you go. Certainly just by Googling things you don't understand. Div is this invisible division of the page. Style allows you to specify some CSS, cascading style sheets. And this one kind of says it all. Text align colon center means everything on this page should be centered, and so forth. So today, and henceforth, we won't focus so much on HTML, but rather how this is functioning as a dynamic website. And the most interesting tag toward that end is this guy here. So we saw forms last week, and a form has an action, which is the URL to which the form should be submitted, or partial URL if it's on the same server. And then there's two methods. And we've seen get and we've seen post. And for now, the simple distinction is get requests end up where? Where do the parameters end up? In the URL, in the address bar. And so get is generally to be avoided for anything sensitive. You don't want passwords, credit card numbers, anything personal going into the address bar with a get request, if only because it's unnecessary. Two, it then lends itself to prying eyes, roommates and such sitting down and looking at your browser history. It's just bad practice. So post is generally preferred for anything sensitive, as in the case of personal information. So what does this thing look like? Well, let's go over to a browser. I am in, recall, localhost, which refers to the appliance, /jharvard. And I'm going to go into my froshIMs directory, froshIMs0.php. And this should look familiar from last week. So register for froshIMs. The fact that I'm using a table is just because I wanted this to kind of line up nicely with rows and columns. But let's see what happens when I register. This form, when I click register, is going to get submitted to register0.php. So let's take a look at what we should expect there. Let me open register0. And this is actually a very simple file. So the stuff at the top, realize, is just comments. And the only reason I put my comments inside of PHP braces is just so that the user doesn't actually see the results. Realize that anytime PHP, or the web server in this case, sees open bracket question mark, those lines are going to get interpreted, and the output is going to get sent to the browser. Well, these are just comments, so there is by definition no output per se. They're not function calls. It's not printf or print or echo, so nothing ends up going. That gets stripped from the resulting web page. But the result is really just some HTML. Most of this is HTML5, except for this line, which is a new function, a very helpful function in PHP, at least for diagnostic purposes, called printr. The R is recursive. So what I'm saying here is go ahead, when you receive a request from a user, create this very, very basic web page with a head and a body, and go ahead and print recursively the contents of a special variable called $_post. And notice that this is indeed PHP because I have flanked it with the open bracket question mark on both sides here. And this is a new tag too for most of you. The pre tag just means use pre-formatted text. Use monospaced font so that it actually looks like programming code and not like Times New Roman or something like that. So this is not a useful web page yet. This is not a freshman intramural registration system. It's really just to see what's going on underneath the hood. So let me go back to my browser. And let me go ahead and type in, for instance, David, Captain, Mail, Matthews. Click register. And what that web page is doing for us is simply this. It's showing us that $_post is apparently an array. And inside of it are a bunch of key value pairs. Those key value pairs are name equals David, Captain, on, gender, M, dorm, Matthews. So here's what's really powerful about languages like PHP. I didn't have to do a thing. I simply called a function that printed out the contents of a default variable that was automatically populated for me by the web server and by PHP, so that now I can focus just on getting the job done that I care about, registering this user. By contrast, in a language like C, you would actually have to parse all of those HTTP headers. You would then have to figure out that, oh, the question mark means a parameter, the ampersand means multiple parameters. You would have to do all of that crazy string manipulation yourself, when now all I care about is getting real work done. And that's what these languages tend to facilitate. So interesting, too, is there was no mention of the word on in the HTML, but this is actually the convention. When you check a checkbox, the value that's sent from a browser, apparently, is literally the word on.